completeness. So expectation of z of t is equals to 0 for all theta greater than 0. So that means z of theta must be equal to 0. So if we consider the PDF of t, so that is nothing but n into t to the power n minus 1 by theta to the power of n for 0 less than t less than theta. So that means 0 is equals to expectation of z of t. So that means n by theta to the power of n integral t to the power n minus 1 into z of t dt from 0 to theta is 0. So if we differentiate on both sides, or so that means 0 is equals to integral 0 to theta z of t into t to the power n minus 1 dt. So this is equals to 0 for all theta greater than 0. So if we differentiate this identity by using Leibniz rule, theta to the power of n z of theta is equals to 0 for all theta greater than 0. So that means z of theta is equals to 0 almost everywhere. So therefore t is also a complete statistic. So first statement is correct. So if we consider the second statement, so x follows f of n, so it's discrete uniform. So x follows discrete uniform. So that means the joint PMF will be 1 by n to the power of n, indicator x of n less than or equal to n. So therefore the maximum order statistic will also be a sufficient statistic even in this case. And whereas for completeness, expectation of n of z of t is equals to 0. So that is equals to, that implies, so 0 is equals to expectation of this. So that is equals to 1 by n to the power of n, summation t is equals to 1 to n, z of t into t to the power of n minus t minus 1 whole to the power of n. So that means summation t is equals to 1 to n, g of t into t to the power of n minus t minus 1 whole to the power of n is equals to 0 for all n greater than or equal to 1. So if we consider this thing, so this is equal to 0. So we can clearly see like z of 1 is equals to z of 2 is equals to and so on. Z of k minus 1 is must be 0, because for n is equals to 1, if we consider z of k into k to the power of n minus k minus 1 whole to the power of n is equals to 0. So this implies z of k must be 0, because k to the power of n minus k minus 1 whole to the power of n is strictly greater than 0. So that means z of t is equals to 0 for all t. So we started with 0 is equals to expectation of n z of t, and we reached z of t is equals to 0. Therefore t is also complete. So that means second statement is also correct. So therefore both 1 and 2 are correct option.